Hi, this is Jude Leonard from Department of Physics, St. Joseph's College of Arts and Science, Cuddalore. Now we are going to discuss about rectifiers. Now, what is a rectifier? A rectifier is an electrical device combines of one or more diodes for converting alternating current to direct current. Naturally, we may have a question, why should we convert AC to DC? It's very simple that AC signals can't be stored while DC signals can be stored. For storing electrical energy, we have to convert AC to DC. For example, all kinds of digital devices requires constant voltages. Thus, we require rectifiers to convert the AC signals to DC signals. And a diode is like a one-way valve that allows the electrical current to flow in only one direction. Basically, there are two types of rectifiers, half-wave and full-wave rectifiers. In half-wave rectifiers, as the name insists, only one half of the input signal is allowed and the other half is removed. As you see in the circuit diagram, one half of the input signal is processed and remaining half is cut off in the output signal. Let us see how it works. When a AC input voltage is applied, the diode in the circuit becomes forward biased. It means that positive terminal is connected to the positive of the diode and negative to the negative. So the diode conducts and we receive a rectified output voltage. But during the negative off cycle of the input voltage, the polarity of the points A and B gets reversed. Thus, the diode becomes reverse biased. We know that in reverse biased condition, diode doesn't work. Hence, there is no flow of current in the output. Thus, half-wave rectifier rectifies only the positive input signal. The major demerit of the half-wave rectifier is it rectifies only half of the input signal. To overcome this difficulty, full-wave rectifier is used. Here in full-wave rectifier, two diodes are used, D1 and D2. During the positive off cycle of the AC input voltage, the diode D1 is forward biased and the diode D2 is reverse biased. Therefore, D1 conducts and D2 doesn't. During the conduction of the diode D1, we receive the output voltage. During the negative off cycle of the input voltage, the diode D1 gets reverse biased and D2 gets forward biased. Thus, both the cycles of the AC input voltage gets rectified in the output voltage. Now we can see the bridge rectifier. This type of rectifier is a single phase rectifier which uses 4 diodes connected in a single closed loop configuration. The major advantage of this bridge circuit is it doesn't require any center tap transformer. While in full wave rectifier we are using a center tap transformer, but in this bridge rectifier we doesn't require any kind of center tap transformer. In the circuit diagram, you can see there are 4 diodes are used. In full wave rectifier, it is only 2, while in bridge rectifier, as we mentioned earlier, we are using 4 diodes in a closed loop structure. The 4 diodes in the circuit are labeled as D1, D2, D3 and D4. All these diodes are arranged in series pairs. Only 2 diodes conduct current during each half cycle of the input voltage. During the positive half cycle of the AC input voltage, the diodes D1 and D2, which is connected in series, becomes forward bias and conducts, while D3 and D4 are reverse bias, so it doesn't work. We get the current, that is output voltage, across the load. During the negative half cycle of the AC input voltage, the diodes D3 and D4 conducts and D1 and D2 doesn't. It means that D3 and D4 gets forward biased and D1 and D2 gets reverse biased. The amount of current flowing through the load is in the same direction as the current flowing through the load is unidirectional, in one-way direction. So the voltage developed across the load is also similar to that of the previous 2-diode full-wave rectifier. Therefore, we obtained the average DC voltage across the load is 0.637 of maximum voltage. Uses of a rectifier. In communication field, the demodulating of the amplitude of a modulator signal is carried over using a half-wave rectifier. And in radio signal, to detect the amplitude of the modulating signal, a full-wave bridge rectifier is used. This video gives some major outline of the operation of full-wave, half-wave and bridge rectifiers. Thank you once again.